Hello friends, in today's question, a cylinder of mass m and radius r is resting on a horizontal platform which is parallel to xy plane with its axis fixed along y-axis and free to rotate about its axis. The platform is given a motion in the x direction given by x is equal to a cos omega t. There is no slipping between the cylinder and the platform. The maximum torque acting on the cylinder during its motion is. So we are given that there is a plane and which is parallel to xy plane. Okay, so let us draw the figure. So this is our x, this is z, and this is our y, and we have a plane which will be something like this. And there will be a cylinder which will be lying on this plane, and you can say its axis will be so sorry, this is y and this is x, my mistake. So this is y axis, so the cylinder will be something like this, and this is the axis of the cylinder which will be basically parallel to the y-axis, and the cylinder is free to rotate about this axis. And this platform is given motion which is represented by the equation x is equal to a cos omega t. So we have to find out the maximum torque acting on the cylinder during this motion when the platform is moving with a equation that is x equal to a cos of omega t. So it is given to us that motion of the platform in x direction is given. So we are going to write it. You can say motion of platform in x direction and it is given as x is equal to a cos of omega t, and from here we can find out the velocity in x direction, and then we are going to find out acceleration in x direction. So therefore we can say velocity of the platform which will be derivative of the given equation. So we can say velocity in x direction is equal to derivative of x with respect to time t, and this will be giving us a minus a omega sine of omega t. And similarly we can find out the acceleration of the platform. Acceleration of the platform. So once again we are going to derivate this equation, velocity equation. So we are going to get acceleration in x direction will be equal to derivative of velocity, and this will be coming as minus a omega square, and this will be cos of omega t. And we can find out the value for which the acceleration will be maximum. Okay. So obviously the cos of omega t will be equal to plus minus 1, then we are going to get the acceleration as a maximum. Okay. And we are only interested in magnitude, so we can say that for maximum acceleration cos of omega t will be equal to plus minus 1, or we can say that maximum acceleration will be equal to a omega square. And it is given that there is no slipping between the cylinder and the platform. Okay. You can see no slipping between the cylinder and platform. So under this condition, that is no slipping condition, you can say the point of contact between the cylinder and as well as the platform should be also moving with the same acceleration. So we can say acceleration of point of contact of the cylinder and the platform should have same acceleration. Both should be moving with same acceleration. Okay. For example, if this is our platform and this is the point of contact of the cylinder, and cylinder is, let us suppose from the side, we can say that this is the cylinder and this is the point of contact. So this point of contact P should be having the same acceleration as that of platform. So though the cylinder as well as this platform, they should be moving with same acceleration so that there is no slipping between the cylinder as well as the platform. Therefore, we can write that under no slipping condition, if alpha is the angular acceleration, so you can say for alpha is the angular acceleration of the cylinder, therefore its acceleration, suppose in x direction, will be also given as ax, and this will be equal to r multiplied by alpha. And from here we can say the angular acceleration will be equal to ax divided by r. So therefore we can also write it here that the acceleration of point P will be also equal to ax, that is the acceleration of platform. Acceleration of point P will be equal to ax, which is equal to acceleration of platform. Point P is nothing but point of contact. So acceleration of point of contact will be equal to ax, which is equal to acceleration of the platform. And for we substitute the value, we get alpha ax is our, you can say if you're interested in magnitude only, omega square cos of omega t divided by r, and for maximum torque, maximum, we have to find out maximum torque. Okay. So therefore we can say for maximum angular acceleration, once again we can say from here that cos of omega t will be either equal to plus minus 1. Okay. So therefore I forgot to mention here minus Therefore, alpha max will be equal to a omega square upon r. So this is the maximum angular acceleration that will be produced under the no slipping condition. Now we can find out the moment of inertia of the cylinder. So we can say that moment of inertia of the cylinder and moment of inertia of the cylinder, and cylinder is rotating about the axis which is parallel to y-axis. Okay, we can say cylinder is rotating about its axis which is along y-axis, Therefore we can write that the moment of inertia of the cylinder will be equal to half m r square, and it is supposed to find out the maximum torque. So we can say that maximum torque, that is tau maximum, will be equal to moment of inertia multiplied by angular acceleration, that is will be also equal to maximum. Now simply substituting the values, we get tau maximum is equal to moment of inertia is given as half m r square, and angular acceleration maximum is given as a omega square upon r. Now this r cancel with this square, so we get the maximum torque will be equal to half m r a omega square. So this is the maximum torque which will be acting on the cylinder during the motion. This is the maximum torque acting on the cylinder during its motion. Okay, and the motion is under no slipping, during the motion under no slipping. So herein the important part is that under no slipping condition, the acceleration of the point of contact will be same. The platform is ax or a maximum, therefore the cylinder acceleration of this point of contact will be either ax or it will be a maximum. So this completes the question. Thank you.